Hi, this is Dr. Prakash, Assistant Professor, Associate Dean, Student Welfare, Department of Civil Engineering, SR University, Varanasi. So today we are going to see a topic in surveying geomatics. The topic is offsets. Offset. Offset is nothing but it's a lateral measurement of your taken at right angle at uh, main survey line. So you can see here. So it is taken from the right angle at the main survey line used to locate documented features such as a building. If there's a building which is located near your major survey line, you are going to use this offset to locate your buildings, your roads, and fences that even that are situated away from primary line of sight also. Okay. So if this is your survey line from this, how much distance a particular object is there. So that objects can be located with help of offset. Okay. So the importance of your offsets is nothing but offsets are crucial in chain surveying. So it allows the surveyor to capture a full spatial context of plotting. For example, if you are if you are going for a surveying, so entire area and every details of a particular plot can be easily identified from this line, which is called as offset. Then ensuring that details are accurately recorded and incorporated, you should incorporate it into your final survey maps or plans. Okay. So offset techniques, what they are using offset technique is nothing but so it is used for measuring perpendicular offsets or oblique offsets or even triangulation methods. So depending upon the requirement and constraint which is available, which is on your site. So these things they are using, right? So now we are going to see types of offset. How many types of there are three types. One is perpendicular offset. Next one is oblique or inclined offset. Third one is swing offset, right? So now we'll see in a detailed way what is your perpendicular offset. So you can see here, so this is your main survey line. So make it as A or B. So this is your chain line where you are going to measure your distance. Okay. So the perpendicular measurement of 90 degrees. So this is your structure which is located. So we have to mark this point, right? So this point should be marked at an perpendicular 90 degree with respect towards your uh, chain line. So this is called as offsets, right? So this is your perpendicular offset. Okay. So it provides most direct and accurate distance from a survey line. Okay. So from the point of measurement, it gives the exact measurement, right? So application, so perpendicular offset are commonly used in documentation locating your features such as you can see here. So there is a tree here. This is your tree. So tree, they are marking a tree at from which point your tree is located. What is the distance you have to measure? So that is the major thing. From this point to this point, what is your distance? It has to be clearly indicated on your graph, right? So and the preferred method for this is most preferable method for your survey. Okay. So measurement techniques such as surveyor use a specialized tool. So they use a specialized tool such as crosstabs or optical squares. By using this, they'll measure the distance from your survey line towards your tree. So the most important thing you should consider on this particular offset is that the offset line should be exactly 90 degree, which is perpendicular towards your channel. So that is a major thing we should observe. So you can mark how many points. See here in this structure, most of the points are marked. So the distance between this edge to this edge is marked, and distance between this edge to this edge is also marked, right? So this kind of measuring your distance and marking your structure with respect towards your major survey line is called as perpendicular offset. Now oblique offset. So last we have seen it is a 90 degree. The same structure when you are marking with respect to incline other than 90 degree. So you can see this is not it is not in a 90 degree. So there are variations on this particular inclination. So the angle should be measured, right? So when you are taking a measurement at an angle other than 90 degree, right, from your survey line to your objects, right? So these offset or this type of offset is called oblique offset. Okay. So for example, some structures are nearby. So there is other structures from here. So it is interrupting your straight survey line. So at that case, you can go from this point to this point and you can measure the distance. The only thing you have to consider in this is you need to know the angle between your chain line and your offset line. So that also has to be measured. In your normal perpendicular offset, you are maintaining a 90 degree with your cross tab. But here you need a compass to measure your angle, because this inclination angle you should know, because if that angle is not known, you cannot locate a particular structure which is away from your circle, right? So this type of offset is called as oblique offset. Okay. So as I said, this is applicable only when the site of your object is not directly at 90. For example, if there is a huge stone here, right, you cannot measure it at 90 degree. So at that condition, you are measuring the same point with an inclination with reference towards your survey line. So this degree you should know, and the distance between your survey line and the subject should be known, right? So this kind of offset marking your offset line is called as an oblique offset. Okay. So next, swing offset. Okay. So this is a rarely used one. Okay. The swing are a perpendicular or oblique distance measured to a subject from a chain line by swinging a tape around the point of a chain. You can see here. See here, there is a point, and this is your major survey line. They had a arc, so the arc is drawn across a survey line, and from that point there's a 90 degree, though the object which is located on any of the string is easily marked. So this kind of marking your existing features of a uh, land which is near to a survey line, this kind of offset is called as oblique offset, I mean swing offset. Okay. So where it is applicable, so the application, you can locate a tree, a poles, a building that lies behind the fence. So behind the fence, you can measure walls and ditches, survey lines. So everything can be easily measured with this. So measuring techniques is nothing but you have to fix a point on a chain line or near the object. So this is your point where you are going to fix. So this is your point where you are going to fix this one. Then you have to hold one tape and you have to swing the other end towards the object. So you from this point you are swinging like this. So it gives a point which is located on your survey line, right? So the object can be easily marked with this, so it records this offset at a swing offset. So this kind of offset measuring is called as a swing offset. So how you are going to mark a perpendicular offset using a square prism square? You can see here. So this is your square prism, right? You are fixing that exactly at 90 degrees. So first you have to locate your point A and point B. You have to align your cross tab or your prism exactly looking towards your point A and point B. Then you have to align this cross tab. You have to go to the opposite direction. You have to ask him to come to this a particular exact line of sight, right? So when the point C and your surveyor is regulating your person who is holding your ranging rod and asking him to come exactly in correlation with your line of sight. So this kind of marking is called as offset using optical squares or prism square, right? So this is widely used. Either you have to move, or the surveyor who is has if their object is here, he will move towards a particular object and then he's mark a distance. So the important thing you should know is that the distance between this A to C should be measured. Make it a D1 or D2 from that C to that particular point. Also, you should know. So once these things you are measuring, then only you can transfer this reading into your drawing sheets or map to locate a particular structure for marking of your offset. Okay, so these things you should be cautious while doing your perpendicular offset. And while you are using cross tabs or your square prism. So this will give you exact 90 degrees. So the same thing they are doing. So from A point, they're asking from C, the server is regulating to align this particular point at D exactly at the line of sight. At this point, the angle between your A to C, ACD will be exactly 90 degree because you are using a cross tab. So here it is clearly given. The work of a surveyor is to ask your point B to align exactly with the line of sight, which is correlating with the same point where they fixed with C. So this is your optical fixing of your perpendicular offset using your optical squares. So now they are verifying the point C and point D are exactly aligning. So once they fix this point C, again they are cross-checking that point A, right? So there, because this is done with uh, done by a surveyor, there may be a possibility of changing in the inclination. So right angle should be exactly measured, so it will be 90 degree to complete the entire procedure in an effective way. So if there's deviation, you fix this and this is not aligning with A means, so then there's a error in fixing your offsets, which is exactly perpendicular towards your main survey line. So once you fixed everything, so point D is marked. So with reference towards your point C, a point D is marked for your reference. So this point is called as offset line. From this, the distance has to be measured. Now, types of obstacles in chain survey. Okay. So obstacle, there are three types of obstacle, which is obstacle in ranging, obstacles in chaining, and overcoming obstacles. You can see here, right? So obstacle in ranging, as you said, while doing your ranging, there may be an inference of your buildings. There may be structure in between your survey line or trees or uneven terrain that is prevent the direct alignment of survey chains, making it difficult to establish a straight line between your points. So this is the thing. So in that case, you have to go for indirect ranging. Then obstacle chaining, there may be physical barriers such as water bodies in between your survey line. There may be road structures or a ditch that prevent a direct measurement. So at that time, you have to use alternative methods for your measuring and a transfer substrate and to remove that alternative transfer obstacles. Then overcoming obstacles. The surveyor employs various techniques to overcome these obstacles. Uh, the surveyor will employ various techniques, including your indirect ranging method, use of indeterminate point measuring about physical barriers. So they can remove these things with your various techniques like indirect ranging, as we say. Then now we are going to see type of ranging. Okay. So in type of ranging, there are the two type of ranging. One is direct and indirect ranging. Okay. So the direct ranging is aligning a survey point. So you can see here from the diagram, you can clearly see this is point A and point B, right? So you don't, if the distance is more than your tape length, for example, make this distance as around 120 or 90. Okay. But your tape, what you are having is only 30 meters. In that condition, you have to align your surveillance exactly in the same line, which is in a straight line between your A and B, because the shortest distance between a two line is called as a straight line. So that's the definition of a straight line. Okay. But you are having a tape only 30 meter, but the distance is more than 30. And make it as 90. We are keeping this as 90. We are assuming this distance may be 90. Okay. So in that condition, you have to fix a ranging rod here and a ranging rod here, right? So a person from this point, he should regulate you to align with your center point, which is aligning with your ranging rod A and D, right? So that is a survey position. The survey stand near one point and usually at point A and look towards your other point B. Okay. So what he'll do, he'll be aligning intermediate point, positioning, adjusting intermediate point between A and B to ensure they lie on a straight line. So that is a major purpose, which is for a major purpose of ranging. And this type of ranging is called as a direct ranging. Yes. So the precautions you should follow while using your direct ranging is that, so it should be a straight line. So it should be for the plumb. So the horizontal thing it should be at 0 degree because it should be for the plumb. If that's deviation, because a person who is holding your ranging rod, they will be above your ground level. Okay. If it is an inclined point, the alignment issues will come. Okay. So to avoid these kind of errors, you have to keep your ranging rod exactly at 90 degree or perpendicular towards your uh, ground surface. You should be perpendicular towards your ground surface. Okay. So here you can see this is point A and point B. They are going to align this in the survey line to fix the intermediate points. So the surveyor at point A, he will be holding a ranging rod, and there's a point B which is fixed with a ranging rod. So he's asking a person in between to fix that ranging rod C, aligning a point C which is in a straight line. So he'll be regulating the person who is holding a ranging rod to go exactly in the line of sight between A and B. Either it is in right side, he'll tell him to go in right side, or if in left side, he'll ask him to go in the left side. So accordingly, they will arrange this one. Okay. Once a point is fixed, the person from point C, he will regulate a person from point D because this is already aligning with your A and B, right? In that condition, so what he'll do, he'll ask the point C and ask him to align the point D. So the person from point C, he will be regulating point D to exactly align with the same line between line of sight between C to B. So this will make your entire position to be in point D. So he'll be fixing a ranging rod here. He'll ask him to fix it exactly at this point, right? From this point, again, he'll be regulating point D to be aligning in a line of sight between C and D. So in that way, they'll continue the entire procedure and they'll fix an intermediate point between your A and B. So the intermediate points are C and D. So which is exactly aligning with the straight line between A and B, right? So this type of arranging is called as a direct ranging. So now we are going to see indirect ranging. So for in last slides we have seen the both your point A and point B are visible, right? There will be some situation when your point A may not be visible for point B or point B may not be visible from point B, A may not be visible, right? In that condition, we are fixing your intermediate point between the in a straight line aligning with A and B is is complicated because the points are not visible. You cannot do the direct ranging. In that condition, you have to go with an other technique which is called as indirect ranging. Okay. So in this indirect ranging, you have to identify the points. Okay. So when point A and B are not visible. Okay. Right. So intermediate points C and D are chosen such a way that from point C you should see point D. From point D you should see point A. In that condition, you have to visible. Okay. Right. First, what you will do, he will ask. He will first from point A. Okay. So from this A and B, so there is a huge hill in between them. So there are trees around them, right? So first they will start. So at some other point they will fix. Okay. So what they will do first, they will fix the two intermediate points from C1 and D1. Okay. So this is A and B. You need more persons to accommodate for this particular ranging, right? So what he will do first, he will from point A, he will see point D. Okay, right? Because from A, C and D should be visible. From B also C1 and D1 should be visible, right? What he will do first, he will a person from point A, he will be focusing on point B and asking the person who is at C1 to move from C1 to C2, which is exactly aligning with the straight line between A and D, right? Okay, so this is the first one. So what he is doing from A, he is seeing towards B and asking a person who is from C1 and asking to move him from C1 to C2, which is in a straight line with the A and D1, right? So then a person from C2 will be focusing on B. A person from B will be focusing on C2 and asking a person from D1 to move from D1 to D2. So in that condition, uh, your D1, your D2 will be exactly aligning with the straight line between, coinciding with your line between C2 and B. So again, what you will do, the procedure is vice versa. So again, the person A will be focusing on D and asking him to align, asking from align from C2 to C. Then a person from B will be focusing on C and asking your C1 to do. So this entire procedure will be repeated until you both your C and D are in a straight line between A and B, right? So this type of procedure is called as indirect ranging. Okay, right? So this is very much important for your ranging because most of the condition your points will not be directly visible. In that case, you have to go with this kind of indirect ranging. Right? Now we are going to see procedure for chain survey. Chain survey. So how you are going to do a chain surveying? It includes almost 10 steps, starting from your step one is recognition survey, step two is station selection, step three is ranging, step four is chaining, step five is offsetting, step six is recording in a field book, step seven is closing the survey, step eight is plotting the survey, step nine goes with error checking and finalizing the plan at step 10. Okay. So now we'll see what is step one. So step one is nothing but to conduct a preliminary inspection of survey area, right? So first, initiating before starting your surveying, you should go to the site and visit the site. Okay. So until your physical visit, you cannot identify or recognize how your site is located, what is the procedure you are going to do, whether what kind of technique you are going to adopt to do to complete your work assigned for you as a surveyor. So everything can be clarified only once when you reach the particular site physically to observe how your site is located, what is the thing, right? So this type of surveying is called as recognized survey. So to conduct a plan inspection of your survey area physically, okay, not in online or in a photograph, you have to visit them physically or you ask your subordinate to go and visit and get the details from them. Accordingly, you can fix what kind of surveying you are going to adopt. I mean, survey technique you are going to adopt. Then station selection. So it is used to establish a survey station at key locations. Okay. So for example, if this is your area, so how you are going to fix the stations, right? So this may be a station A, station B, station C, and station D, right? So if it is irregular thing, you will be having another one which is station E. So you have to fix a station from which you are going to start and measure the area, right? So depending upon the location, depending upon the topographical boundaries of the area survey site, this varies. Okay. Next one is ranging. Okay. So ranging, just now we have seen what is ranging. So you are aligning a chain or tape in a straight line between the station, right? So you may have a 30-meter chain, but aligning them, the distance may be more than 500 or 600 meters. So you have to fix intermediate points between your survey stations, right? That point should be in a straight line, right? So that can be achieved only by ranging. Okay. Next one is chain. So once you fix your survey line in a straight one, right, then you are measuring a distance between station using a chain or tree, right? So the main purpose why you came for measuring is to measure the distance, right? So before that, you have to do these many works before starting your measurements. So this many work should be carried out in an effective way so that this many work should be carried out in an effective way so that you are going to measure a distance in a precise and straight as per the procedure. Okay, right? So this at the step four only you are going to measure your distance. Okay, then you are going to after marking measuring your distance between your stations, you are going to offsetting, right? So you are going to mark the existing structure. For example, this is a structure. So if there is a structure located here, if there's a building located here, what is the distance between your main survey line towards the particular structure or object? So this is very much important because you took a plot of an area and a distance of a surveying, right? You are planning to build a house, right? So before doing your planning, before drawing your planning, you should know where is the what are the structures located within your site. Okay, if there's a tree, how you are going to remove the tree, or you are going to keep the tree accordingly, you are going to construct your house, whether in which direction you are going to move your house, in which corner of your plot you are going to construct your house, everything will be planned only when you know what is the existing structures or object or natural phenomena on your particular enclosed plot area. Okay, so this can be done only by offsetting, as we have seen earlier, right? Then every details we are measuring, because this is very much important on your before doing your planning, because if you are not visiting your site, you started planning everything, you spent lot of days of work on doing this, you are planning, and you are getting a very clarification and getting making your client satisfied once you straight away go to the site. Okay, so your site may not be exactly rectangular, it may be a parallelogram. So this is a huge issue what we face often, but the thing is, you have to visit your site to check whether it is in exactly which orientation it is there, what direction your maximum distance are covered, in which direction your plot is oriented, what is your largest distance on which direction, what is the shortest point on which direction, everything should be noted, right? So after doing these many preliminary work, then only you should go for your plan. Right. So if you're just getting started drawing a plan for a particular site without visiting a site with your drawing on a book, there may be huge issues when you're executing your plan on your site. So to avoid these things, everything should be done in a proper way, right? So after your offsetting, you are going to record it in a field book. So this is very much important. You should be precise and cautious while doing these things. So to accurately document all measurements and features in the field book, right? So the measurement what you're measuring should be exactly marked on your field book, because that measurement is the data what you're giving towards your client regarding your survey, right? So there should not be any mismatch. There's a huge possibility of human errors, because there will be a lot of people involving on this entire process, right? So there may be miscommunication and there may be missing of any data. So if any particular data is missed, if it is complicated, it may cause to a cumulative error. So if it is a cumulative error, again from the first you have to start your surveying, and again you have to do the entire work from the first. So to avoid these things, you should be very precise and very cautious on while doing your measurement and converting your data from the measurement towards your drawing, okay, to a document. Then once everything is completed, you are to ensure accuracy of your work, you are closing your survey at the end of day, or you are continuing at the next day, depending upon how much you are assigned. Okay. So you are closing your survey. Then after that, plotting a survey, right? So this is very much important. You record a data on a rough sketch, then you are converting your data into a proper understandable sketch. So that is your work which is assigned to you. So to plot a measurement on a paper to create a map for the client. All right. So you are converting your entire raw data into a usable data with the help of you are plotting it where either you can use any software or you can give in a sketch. Okay. So the data what you have took should be directly converted into a map or a plan, right? So that is the major thing. There should not be any issues or mismatch from your site towards your drawing, because there may be a project, because with the data what you are giving, your planning engineer will start planning, drawing a plan from on the particular details what you have provided in your paper, right? So those things you should be so cautious on these things. Then error checking. So to ensure the accuracy of error, you have to cross-check it with your plot. So error should be removed well in advance to avoid these things. So error checking, it has lot of error checking techniques. So according to your requirement, you have to adopt one method which is specifically useful for the particular work. Once everything is done, you have to give your final map or plan of survey towards your client who have assigned you that work. So this entire procedure should be precisely followed to avoid any misconception between the client and the contractor, or client and between client and you, right? So this gives you exact output of a survey area which can be replicated once or twice for the requirement of further processing or further planning. Next, errors in chain surveying. So up to last we have seen what is the procedure for doing chain surveying. Now we are going to see errors and correction in chain surveying, specifically on tape, which is temperature, pull, sag, slope. And regarding that, we'll see some numerical problems also, right? So there are two type of error. One is cumulative error, another one is compensating error. Okay. What is cumulative error? So cumulative error is nothing but, for example, if your tape is less, the larger or smaller, which is other than your standard SI unit. So if it is 30 meter, but your tape is only 29.9 meter. Due to some issues, it is 29.9 meter. In that condition, the measurement what you're measuring from the start of a day to end of a day is deficient by 0.1 meter. It means there's a deficiency of 100 mm on a tape, right? So this kind of error which is measured on the same direction is called as cumulative error. So the error will be keep on accumulating for a larger number of times, right? For a huge number of times. So this error cannot be revoked. So this cumulative error will be keep on at what fine day, because for each measurement you are missing 100 mm. So on at the end of your survey day, so the error is keep on accumulating. So this kind of error is called as cumulative error. Next, we are going to see compensating error. Okay. So compensating error, it occurs in either direction and tends to cancel out. So if you find it earlier, so there may be issues in this. So for example, if you are doing any measurement which is on the particular directions and you found that is a very minimal error, right? So it is between a single directions. So once you are measuring, and that can be compensated because it is not cumulative. So initial stage we are taking in one direction and it can be eradicated instantly, right? So this type of error is called as compensatory. It will not be keep on accumulating as a cumulative error. So you can ignore or you can identify well in advance, right? So the errors are positive when the results are too great, right? So the error will be positive error when the results are too great, and error will be negative when the results are too small, right? So this is vice versa. Your error will be positive. The error is inversely proportional towards your result. Okay. So if the error is positive, so it is inversely proportional towards your result will be negative. If the error is negative, and the result will be positive. So these are the major types of error which is occurring during measurement of your chain survey. Okay. And thank you